Xiang. I'm doing this video for the optical handwriting digits recognition, and here's my PPT. In the first part of the PPT, I will talk about the introduction of this product, and the second is dataset description. The third is handwriting extraction, and next we'll do the description for algorithms, and the next we do the results based on SVM and KNN algorithm, and finally we do the conclusion of this PPT. Let's first talk about the introduction. Typically, optical character recognition means we convert the handwritten character into machine code. We use an electronic device, for example, a digital camera, to check character printed on paper. And in this project, the identity indexing procedure was performed in the following way, which I will introduce below as dataset description in introduction of two algorithms. Like we said, there's two algorithms I will use in this project: the support vector machine algorithm (SVM) and the k-nearest neighbors algorithm. And next we talk about the dataset description. The available dataset consists of total 11025 dots set as 32 times 32 dots. To better simplify the dataset, I will change it into 8 times 8 dots. In general, the provided dataset is not anything standard, and the samples could possibly lead to erroneous predictions. Under these circumstances, the recognition algorithm is hard to implement. To find a better way to increase the accuracy, we will use several procedures in hope to maximizing recognition rate. And after that, I'll talk about the handwriting extraction. The first and most important step for nearly all handwriting digits recognition algorithm is digit extraction, or we talk it like digit detection. The main purpose of this step is to extract these digits on image. Like we said, here is a example for that handwriting digit. Then we use an electronic device to check character printed on paper, the digits in text document, into image files, black and white dots, by using optical method. After that, convert the text in the image into text format through recognition software for word processing software, further editing and processing technology. And you can see here is my dataset, and I can show this on desktop like this. This is my dataset. The first 64 digits are the input, and this is output 0. The first output. Let's continue. And after that, I'll first talk about the SVM algorithm. SVM algorithm is a method through a nonlinear mapping. Mapped the sample space into a high-dimensional and infinite-dimensional feature space. We call it Hilbert space, so that in the original sample space is transformed into a nonlinear separable in feature space, linearly separable problems. By using training data D, we can get the points of the form like this, and in this formula, yi is either 1 or minus 1, indicating the class to which the point xi belongs. Each xi is a minus p-dimensional real vector. After the optimization process, we can get this. We know that the SVM, there's two typical forms: the primal form and the dual form. Let's first talk about the primal form. We use the standard quadratic programming techniques to get the expression of the primal form like this. And after that, we let the last one, the primal form, subject to alpha I upper than 0, And the constraint from minimization, we get the alpha dual form. Alpha dual form as like this: the sum of alpha I times yi times xi. After the simplified description of SVM, we give some background information of KNN algorithm. K-nearest neighbor classification algorithm is a more mature approach in theory. Also, it can be called one of the simplest machine learning algorithms. The main purpose of this algorithm is that if a sample in feature space of K most similar of the sample belongs to category to this category. Here is an example of the KN algorithm, and we can see it on here. After that, I just want to talk about the result based on these two algorithms. In this project, we both use the support vector machine algorithm and k-nearest neighbors algorithm, and I will compare the accuracy of those two algorithms. Let's first talk about the support vector machine algorithm, and I'll do this program running in software. Here's the SVM algorithm. We open this file here in the document is in desktop. Okay. This is my program, and I will run it. I use this spider. Let's open that SVM and run. Now we get the result, and it can show that the accuracy of this algorithm is 0.5, 50% accurate, 50% not accurate. Okay, let's continue on my PPT. Okay, here's the result I just gave. I did that picture's bigger to better explain. Our data sets have 2900 data. We used first 2351 data as training data to test the working condition and the accuracy of the algorithm. And after that, we used the rest 549 data to do the formal test. The result I just showed in that software like this, the accuracy is 0.5. And after that, we talk about the k-nearest neighbor algorithm, and I will show it. Here is my program, KNN's algorithms program, and let's do it. Open it. And for this program, you can see in this part is the input of my data set, and this part we do the training. Like I said, we use the first 2350 data as training, and then in the next part we get the result, we get the picture. Let's run for this. Okay, like we see, this is the result, and the surprise is by we use KNN algorithm, the accuracy is much higher than SVM. The accuracy is nearly 99%. 99% of data is correct. Okay, and now I want to change the k value for this because it's called k-nearest. So I'll change the k value. Like here, now my k value is 2. Now I want to change it into 50 maybe. Let's see what will change. Okay, now like we said, when I increase the k value, the accuracy decrease. Now it's 96% of the data is correct. Okay, let's be back to my PPT. I do actually 6 different k value to my experiment. K equals to 1, 2, 6, 10, and 50, 100. And finally, I get a table for this. We can get different accuracy with different k value. Here we use a table to better show the influence of accuracies by k value. You can see finally, I do the conclusion. Finally, we can conclude that for a project, the accuracy for KNN algorithm is much higher than SVM algorithm, and so it is better to use KNN algorithm to do the optical handwriting digit recognition in my project. And based on the result of KNN algorithm, when K value is 2, we can get the highest accuracy for the digit recognition. Like here, when K equals to 2, the accuracy is the highest. Okay, I think that's all for my project. Thank you for Professor Wu.